Hello and welcome to this episode of Math with Martinez. In our video today, we are continuing our look at fundamental skills and factoring polynomials. I want to begin by looking at factoring trinomials in this video. Now, a trinomial, as we've discussed previously, are polynomials with 1, 2, 3 terms. And they are typically written in this format, where a is our coefficient of our squared term, b is the coefficient of our linear term, and c is our constant. Now, when we are asked to factor a trinomial, it's typically going to fall into one of these two kinds of categories, where you have this easy style. That easy style is when your a is equal to 1, that a being the coefficient of your squared term. Now let's check and see, can we find any like that? Can we find an easy factoring trinomial? Yes, absolutely. We've got one right here, this very first one, because our a is a almighty 1. It is an easy factor that we have for problem 15. Let's go ahead and just maybe make a little note here that this is the easy style. Another easy one would be, which other problem is easy? Yep, we can have this one, and that looks to be the only one. The others are not of the form that we see. If you thought 17 was, be very careful, look at that exponent there. That is a little bit different, and we will get to that one. But these first two are both easy factors, easy trinomials to factor because our a is a 1, a being that coefficient of x. So how do we factor these? Well, let me go ahead and show you guys. I like to use this cross method to identify the factors. When I say it's easy, I know that my answer is going to look like a binomial times a binomial, where the first terms in each of the binomial have to multiply together to give us m squared. And so that means that they're both going to start with m. What we're trying to find is what's going to be the value here and here. Those values, those constants, they're going to need to multiply to give us the negative 30, but add to give us a negative 13. So here's how I organize my work. I put my b value in the bottom of this cross. Actually, let me clean that up a little bit because I can't seem to fit it in there. Our b value is going to go in the bottom. And what is that b value? Our b value in this case, check it out, check it out. Let's get our little highlighter. What is our b value? That b value is the negative 13. That's our b, so we'll go ahead and put that in the bottom, negative 13. And then in the top is a times c. Our a value, which we already identified was a 1, times our c value, which is our constant, negative 30. So ladies and gentlemen, what multiplies to give you a negative 30, but adds to give you negative 13? What two numbers will work there? All right. Well, ladies and gentlemen, those two numbers are negative 15, and a positive 2. If at first you thought 3 and 10, unfortunately that will not work because you could never multiply them and get a negative and also add and get a negative. But those two values right there are the values that will finish our factor. So we've got our answer, we've got our two binomials that when multiplied, together are the original polynomial. And we used the cross to help us find the constants in our binomial, just as a way to organize our thoughts. So why don't you guys try problem 16, and then we will check it together. Can you guys go ahead and try to factor problem 16, and then we will check it together. All right, well, it is an easy factor. So I know that my final answer is going to be two binomials, so that when multiplied, a times a will give us that a squared. The a times the a gives us our a squared. I just need to find the constants that will finish this off. So I'll use my little cross. The b is going to go in the bottom and ac on top. What is our b value? What is our b value? That is an 11, and our a times c is a negative 80. So what numbers will multiply to give us a negative 80, but add to give us 11? I know that one is going to have to be negative and one's going to have to be positive. The bigger one is going to have to be positive, and that is 16 and a negative 5. When multiplied, they give us negative 80. When added, it is 11. So that will finish off our factors. There we go. All right. Now, ladies and gentlemen, what if we do not have the easy style? What happens when our a is greater than 1, but it is still this quadratic trinomial kind of setup? Well, we are still going to use the cross, but it's going to be requiring a little bit more from us. So take a look at 18. Looking at 18, I recognize that I've got this a value of 2, a b value of negative 13, and a c value of a negative 7. So we'll use our cross to help us organize. B goes in the bottom, and a times c goes on top. My b value was negative 13, and a times c, that's 2 times negative 7. 2 times negative 7 is going to be a negative 14. So, ladies and gentlemen, what multiplies to give you a negative 14 but adds to give you a negative 13? We often are thinking like we overcomplicate this sometimes. Let me show you how we can do that, how we can make it less complicated. Start small. 1 and 14 multiplied to give us 14. Voila. And if we make this one negative, boom, that will be the value that completes our little square. And so that is what we use to split our middle. We're going to say, instead of these 3 terms, it's the same thing as 2d squared plus 1d minus 14d's and then minus the 7. Did you see how what we did was we took these, we take these quantities and use them here to split the middle. From there, ladies and gentlemen, we look at the first group and we identify what would be the GCF. What's the greatest common factor that we can divide out of both? It is just a D. And what would remain inside so that when you multiplied it would go back? It would have to be a 2D and plus 1, because D times 2D, D times 2D is in fact 2D squared, and the D times 1 is 1D. Now we similarly will work with the next one here. We have the GCF of negative 14D and negative 7. That's going to be a negative 7. And then what would be inside? Negative times a positive 2D, and a negative 7 times a positive 1 gives us that negative 7. All right, just about done, ladies and gentlemen. Now, to finish it off, one of our factors is look at here. One of our factors is our GCF, because they are both of those, the D and the minus 7, are multiplying with 2D plus 1. So instead of saying D times 2D plus 1 and negative 7 times 2D plus 1, we can just say D times negative 7 times that binomial. So that is when you're working with trinomials of the form ax squared plus bx plus c, where your a is not equal to 1. Now, that leads us into 4-term polynomials. How do you factor those? Well, like we just did, if you've got 4 terms, group them up. Group up the first 2 and the last 2. From this first grouping, what would be our GCF? From that first grouping, we have an h squared as our GCF, and inside would be left a 2h minus 3. From our second grouping, what do we have? What would be our GCF? That would be a positive 3. Leaving inside, if I divide 6 by 3, or 6h by 3, that's 2h. And if I divide that negative 9 by 3, it is a negative 3. So once again, we've got this really unique setup where h squared is multiplying with the 2h minus 3, and the 3 is multiplying with the 2h minus 3. So our final response would be h squared plus 3 is multiplying with the other binomial 2h minus 3. So there you have it, ladies and gentlemen. Why don't you all try this one right here? Can you guys try 22? Try 22, and this will be the last one that we do in this video. Take a moment to try factoring example 22, and then we will check it together. All right. So here we have group up the first 2, group up the second 2. From the first grouping, our GCF is z squared, and left inside would be a z plus 7. From our second grouping, the GCF would be a negative 5, because we can divide a negative out of both of those, and the result is a z and then a plus, because the negative times the positive gives you the negative, and then once again 7. And this is exactly what we wanted. We've got the values here in front, our GCF and our GCF, and they are both multiplying with this z plus 7. Both of them are multiplying with that z plus 7, just like we saw here, right? Just like we saw. And that would be there. The h squared and the 3, those were both the GCFs, and that was one of our answers. So we need to set up our final answer here in the same manner. Our final answer would be the GCFs, which is z squared minus 5, and the z plus 7. So there you have it, ladies and gentlemen. Those are the examples that I wanted to go through with you all in this video. If you had any questions about factoring trinomials or polynomials by grouping, will you take a minute to share those now? And until next time, stay fired up, you guys.